this is Howie. In this video, we're going to be exploring fractions, derived from the Latin word fractio, meaning to break. Let me explain why fractions are just like me. You see, my friends know me as Howie. My students refer to me as Mr. T. To my own kids, I'm just Dad. And to the gamer world, I'm Sir Dragon. Now you're probably wondering what in the world any of this has to do with fractions. Well, let me explain. Just like I can have many different names, all while staying the same person, a single fraction can also be called many names without its value changing. Let's explore. You may be familiar with the way fractions are written, with the numerator on the top and the denominator on the bottom. Let's first focus on the role of the denominator. Consider this fraction model. I like to think of it as a candy bar. Ooh, yummy. Unfortunately for you, I'm not going to give you the whole candy bar. You're going to need to break it into parts. 3 equal parts. That means the denominator is 3. The denominator tells us how many parts to divide the whole into. How many cuts will you need to make in order to separate the candy bar into 3 equal parts? Where should you make those cuts? Pause the video to think about it, and then press play. You will need to make 2 cuts in order to separate the candy bar into 3 equal parts, or in this case, pieces. Perhaps you decided to break the candy bar up using vertical cuts. 2 cuts, 3 equal pieces. Now it's also possible you decided to divide the candy bar up using horizontal cuts. Let's see how that looks. Once again, 2 cuts, 3 equal pieces. Now it really doesn't matter whether your eye saw to cut it vertically or horizontally. The truth is, we're going to use a combination of the 2 cuts to find the many names of fractions. But let's start with the vertical model for our example. 3 equal pieces. If I offer you 1/3 of the candy bar, that means that you can take 1 of the 3 pieces. In this case, the number 1 is the numerator in the fraction. That part shaded in yellow, that 1/3 of the candy bar is yours. But if I was feeling a little trickier, I might have told you to cut the candy bar into 6 equal pieces. Do you see a way to go from 3 equal pieces to 6 equal pieces? This is a great time to combine a horizontal cut with our vertical cuts. With 1 horizontal cut, I have created 3 additional pieces. Notice how the size of each piece is smaller. If I am to still offer you the same amount of candy bar, 1/3, the part shaded in yellow, how many pieces should I offer you now? As you can see in the model, I will need to offer you 2 pieces. 2 pieces sounds like it's more than 1, but I'm actually still offering you the same amount. That's because 1/3 of the candy bar is equal to 2/6 of the candy bar. 2/6 is just kind of a nickname for 1/3. In fact, 1/3 has countless nicknames. Take a look. With each additional horizontal cut, it's like I create 3 additional pieces. And of those 3 pieces, I'll offer you 1 more. So if I wanted to cut the candy bar into 12 equal pieces, I would keep making horizontal cuts until I reached 12 pieces. 6 equal pieces. 9 equal pieces? 12 equal pieces, and you will get 4 of those pieces. If I was to cut the bar into 21 equal pieces, how many of those would I need to offer you so that I was still offering the same amount? Pause the video to solve this problem, then press play to check your work. With each horizontal line, it's like I'm creating 3 new pieces. 6 pieces, 9 pieces, 12 pieces, 15 pieces, 18 pieces, 21 pieces. And of those 21 pieces, I will need to offer you 7 pieces. Notice how when I broke the candy bar into 7 times as many pieces, I also offered you 7 times as many pieces. 1/3 and 7/21, they're the same thing. In conclusion, me and fractions, we're just alike. We've got a whole lot of names.